Friends, we will continue to discuss the last lecture in module 2, which is lecture 14. In this, we will discuss the extension of non-destructive evaluation as a second series lecture, which is a continuation of the last lecture. Based on the incidence of the transducer, with respect to the surface, waves may be created. It may be P waves, S waves, or their combination. These waves detect anomalies around the sound path they travel. In pulse echo method, defects are detected in the form of echoes. Alternatively, in pitch catch method, flaws are detected by wave dispersion caused due to damage. Pitch catch method is suitable for embedded non-destructive evaluation. This method can be used to detect the structural changes that take place between the transducers. One transducer will be placed as a receiver, another transducer will be working as a transmitter. So, between the two transducers, one is a receiver, other is a transmitter. The changes take place between these two will be able to detect the flaws or the damages on the structure which is being examined. Pitch catch method can detect changes that are created by guided wave amplitude, phase difference between them, and their dispersion. This method has the following applications. corrosion detection in metallic structures, damage detection in composite materials, detection of debonding in adhesive joints, detection of delamination in layered composites. In the embedded method, of non-destructive evaluation, transducers are permanently inserted either between the layers of the composites or on the structure. They are actually attached to the structure permanently. Now, let us see what are the advantages of crack detection in metallic structures. Friends, cracks in metallic structures generally form and propagate perpendicular to the surface. Generally, it can cover the whole thickness. If it covers the whole thickness, in such cases the crack is called through thickness crack. The consequence of this, of such crack, is that it can tear the metallic structure. In the conventional NDE, cracks in metallic structures are generally detected with ultrasonic or eddy current probes. One of the limitations of this they can detect cracks or flaws only at particular points. If one need to examine crack presence of the whole surface, one should have to manually scan over the complete surface to detect cracks. This is a very tedious exercise, and this has a possibility of oversighting a few crack locations. This can be avoided. This problem can be corrected by pitch catch method. In pitch catch method, guided waves are transmitted from one location and received in another location. Thus, the whole member or material is analyzed for 1, the guided wave shape and its amplitude, the phase lag created between the end signals and change in amplitude. These will help us to detect presence of cracks without manually scanning the complete surface. So, this can be seen as one of the important advantage of pitch catch method of NDE when it is used for crack detection in metallic structures. Pitch catch method can detect presence of crack and also their extension. Without scanning the whole surface manually. Now, there are researchers who ascertain that probability of crack detection by pitch catch method is much higher than other methods. This is given by the following relationship. Probability of crack detection by pitch catch method is equal to sum of cracks recorded by pitch catch method divided by m minus n plus 1, where m is the number of crack events recorded by non-destructive evaluation method, and n is number of serial events. It is very important to note that pitch catch method is also effective in detecting fatigue crack propagation. Additional reading on this subject more can be seen from the following reference. Shock and Vibration Digest in the year 2005.